Okay, so welcome back. Now that we've got the table set up, it's time to do this. So we've got 200 people. We're asked each one what they do to get to work. They want us to create the probability distribution, so we're going to do that. We had 153 drive alone. 153 divided by 200. That's 0.765. Okay, that's that one. We had 22 carpool, so 22 divided by 200. 0.11. Next one, 10 public transport. 10. This is 5.05. Okay. We have walk, which is 5 out of 200, which is half of that, 2.5%, 0.025. Next one, we had 3 people who other means it's 7. So 3 divided by 200, oops. 0.015, and 7 divided by 200 is 0.035. Okay, so now this is our probability distribution. We've got that figured out. Estimate the probability that a randomly selected individual carpools to work. So carpool is 11%. There's 11% chance that somebody carpools to work. Another way you could say that is about 1 in 10 people from this survey carpool to work. I think it's safe to say most people drive alone. And would it be unusual to select someone who walks to work? So if we look at walks to work, walk is 0.025. We convert that by moving this 2 times to the right. That's 2.5% chance that the person walks, and since that's not like a life-threatening thing or extremely high or extremely low, it would be pretty odd, right? Because there's only 3 people or 5 people to pick out of the 200, and you just randomly picked one of them. That's pretty low chance, so I would say it is unusual to pick that person or one of those people. The classical method does not require an experiment but relies on counting. This method requires equally likely outcomes. For instance, rolling a die, any given number is an equal outcome. So, number of ways that E can occur and number of possible outcomes. This is P of E, and then the N of E is the number of outcomes that are in favor of E, and the N of S is the number of total outcomes from the sample space. So that's pretty straightforward. Example problem: a fair dice is rolled. A pair of fair die is rolled. Fair die are die which each outcome is equally likely. Compute the probability of rolling a 7. So how many 7s are there? That's a 2. So we want 5 and 2. No, 6 and 1. 5 and 2. Oh, it's just diagonal. It's the ones in red. There's 1, 2, 3, 4, 5, 6 of them. 6 out of how many different ones? There's 36 different outcomes. So that's a 1 in 6 chance. Compute the probability of rolling snake eyes. That's 2 1s. So that would be the first one. That's 1 out of 36. And then comment on the likelihood of rolling a 7 versus rolling a 2. Wait. Rolling a 7 versus rolling a 2, yeah. So you're 6 times more likely to roll a 7 than you are to roll a 2 or a snake eyes. So that's one interpretation of it. Sophia has 3 tickets to a concert. We talked about this before, I believe. And these people want to go. To be fair, she randomly selects 2 people. Determine the sample space of the experiment. In other words, list all possible outcomes. So we could do that. Okay, let's see. We have Yolanda, Y, M, and K. Y, M, K, and M. Wow, that's not good. Where is it? Y, M, K, and let's put A for Marissa, I guess. So how many possible outcomes are there? So we have YM, YK, and YA. That would be those sets of people. We have MK, MA, and then we have KA. Okay, so one thing to point out, if you do MY, that's still Michael and Yolanda, so that still matches this one. That's why we're not including it. So it says, what's the sample space at the n size 2? We have that. There's 6 of them. Compute the probability of Michael and Kevin. Well, Michael and Kevin is this one. There's 1 out of 6 chance. That's part B. Here's the 6 total possible. Part C, compute the probability that Marissa attends the concert. Anyone with an A in it. This one, this one, this one. So it looks like a 3 out of 6 chance, so that's a 50% chance. And finally, interpret the results of part C. So Marissa will attend the concert basically with a 3 out of 6 chance, but there's about a 50-50 chance she's going to show up to this thing because she's going to get picked. What kind of a friend buys 2 tickets when they have 4 friends that want to go? Anyways, suppose that a survey of 500 families with 3 children to disclose their genders of their children and found that 180 have 2 boys and 1 girl. Estimate the probability of 2 girls and 1 boy using the empirical method. Calculate the probability using the classical method. Are they equally likely? I'm going to do this in the next video. Okay, thanks for watching.